Let me start this one off with a joke. An infinite number of mathematicians walk into a bar. I'm going to draw a couple of mugs here to help set this up. First mathematician walks up to the bar, talks to the barkeep, says, hey, I'd like I think he ordered a juicy juice. So he ordered one juicy juice, which of course would fill up a mug. So here's a juicy juice. All right, so he got his juicy juice and was happy and went back to his seat. The next mathematician walked up to the bar and said, barkeep, I'd like half a juicy juice. So it'll be about half of this mug right here. So there's half of a juicy juice. Apparently it's blueberry flavored or something. Satisfied, the mathematician went back to his seat. Next mathematician walks up to the bartender, says, I'll take a quarter of a juicy juice. So that'd be half of a half, so that'd be about this much more juicy juice than what we've already talked about. And then next guy says, all right, well, I'll take an eighth of a juicy juice. That'd be another half of a quarter, so there's an eighth here. And then next guy walks up, bartender rolls his eyes, says, hey, what do you want, 16th of a juicy juice? He says, yeah. So there's another 16th of a juicy juice. And remember, there's an infinite number of mathematicians here, and so the bartender finally throws up his hands and says, guys, chill out. I know what you want. And he just finishes pouring the second beer. Juicy juice, excuse me. You know what, I'm going to keep that. All right, so anyway, so that's the idea, is that if you add up 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, bartender would say, why don't we just pour 2 drinks and be done with it? So yeah, that's a hilarious math joke, right? But it's backed up by the idea of a geometric series. So let me define that for you now. Geometric series is a series that behaves like this up here. The most general format for a geometric series would be adding up from n equals 0 to infinity. The terms are ar to the n power, and a and r are real numbers. So keep that in mind. And it turns out that there's 2 cases here. It converges to the formula a over 1 minus r when the absolute value of r is less than 1, and it diverges when the absolute value of r is not less than 1. It's greater than or equal to 1. So we like geometric series because not only can we easily tell when they converge or diverge, but when they converge, we have a nice formula for it. Let me prove that formula for you real quick. I'm going to prove for when r is less than 1. I'm going to prove that convergence formula for you. Now, it turns out the way we do this, of course, the value of a series is going to be the limit of its partial sum sequence. Remember that Sn would be adding up the first n many starting with 0. So ar0 plus ar to the 1 plus ar squared, and we'll stop at ar to the n. And there's a trick to this. What we're going to do is we're going to multiply both sides of this equation by r. So rsn, that becomes, let's see, ar to the 0 plus 1. Ar, here's one r, but now there's another r, so it's squared. Now there's a cubed r here. And then we get ar to the n plus 1. Let me go ahead and write the term before. Ar to the n would come before that, right? And the trick is, well, let's subtract these. Yeah, bear with me here for a second. If we subtract these, we get Sn minus Rsn, and it's sort of like telescoping series. We've got this AR1, and we're subtracting this AR1 here to the left. This AR squared cancels with that AR squared because we're subtracting the entire left and right here. There's an AR cubed here, which cancels with this AR cubed, and then eventually we'll stop when we cancel ARN with ARN, and the leftovers are AR0 minus, because we're subtracting AR to the n plus 1. Of course, what is AR to the 0? That's just A, and I can factor out an Sn over here to get 1 minus R, and I've got A minus A R n plus 1. Okay, then I can divide by the 1 minus R because R is not equal to 1. So I get that the partial sum sequence can be simply described as, we'll factor out an A of here, 1 minus R to the n plus 1. It's got A over 1 minus R times 1 over R to the n plus 1. Alright, so it's a little tricky to figure out how to set this up, but now if I want to know what the series value is and show that it converges, the series of AR to the n's is the limit of the partial sum sequence. And remember, the only variable is n. Everything else is considered constant with respect to that limit. And so all we really care about is A 1 minus R 1 minus, what is the limit as n goes to infinity of R to the n plus 1? Well, remember, the absolute value of R is less than 1, so one of our limit rules is we think of that as fractions. We raise a fraction to a bigger and bigger power, that fraction gets smaller and smaller and smaller, this and eventually limits to 0, and 1 minus 0 is nothing, and that's why we get convergence to A over 1 minus R. So there's that formula, and that ends the proof there. Okay, so now we have this proof, and the most important thing is knowing that the proof only works when you have a fractional ratio. That R is often called a ratio. That's why we use R, and that A is just some constant coefficient here. And when the ratio is actually a ratio, it's actually a proper fraction, less than 1, could be negative, that's fine, then we get convergence, and if it's 1 or bigger than 1 or negative 1 or less than negative 1, that's going to cause divergence. Anyway, let's go back to the joke, right? That's what we're here for, math jokes. And we were asked, basically in the joke, we were asked to take the sum of 1 plus 1/2 plus 1/4 plus 1/8. Okay, how do I figure that out mathematically without drawing a picture? Well, what we can do is we can express this infinite sum as the series n equals 0 to infinity, and look what we have here. Here we have 1, which is anything to the 0 power is 1. Actually, let's write it out as the sum. So this is 1/2 to the 0 power. This is 1/2 to the 1 power, of course. 4 is 2 squared, that's 1/2 squared. 1/8, 8 is 2 cubed, so that's 1/2 cubed. So this is the series, n equals 0 to infinity, of 1/2 to the n. Now remember, a geometric series is a series of the form n equals 0 to infinity, AR to the n, and as long as the R is less than 1, such as 1/2, or the absolute value of 1 is less than R, that's going to end up converging to A over 1 minus R. Oh, what's my A though? Well, the A is just some constant coefficient, so it could be like a 1. There's my A, and the 1/2 is my R, and sure enough, R, absolute value of R is less than 1, so that's my check mark there. Anyway, that gets me that the value of this convergent series, and we know it converges because the ratio is less than 1, that's going to be A is 1 over 1 minus R is 1/2. 1 over 1/2 is 2, just like we saw when we drew a picture a moment ago. All right, let's take a look at another. So we've got a series, and we're asked to show if it converges or if it diverges, and we're also told that if it converges, tell me what its value is. So we just learned about geometric series, so it might be useful to kind of figure out what geometric series is this? Is this a geometric series? So what we need to do is rewrite it in the form of, we've got, and don't worry about the k, oh that's a typo there, that should be 3k plus 1, so fix that problem there. And notice that the fact that it's k is equal to 0, don't worry about that. K, whatever this is, that just takes the place of our n that we usually use. And we want to write this in the form of a r to the n. All right, and when we write like this will be, so again, sorry, to the k. Of course, if you want, you could also just change all the k's to n's, and that would also work. Doesn't matter, it's just a relabeling. Okay, so what we have here is, well, I've got a 3 to the k on the bottom here. So that would be, and that's all I've got. So that's like a 1/3, right? In fact, if it helps, let's do an intermediate step here where I factor out the 2, and I've got 3 to the 1 and 1 over 3 to the k. That'd be the same thing, right? Because 3 to the 1 times 3 to the k, you add those exponents to get k plus 1. So 1 over 3 to the k is the same as 1/3 to the k, because 1 to the k is always 1. And then here I've got 2 over 3 to the 1 is 2/3. All right, so we've rewritten it. There's my a, there's my r, and note that 1/3, the absolute value of 1/3, is less than 1. So we do get convergence. We don't even have to compute it to know that it does converge. If we want to compute it, we can use the formula. A over 1 minus r is a is 2/3. 1 minus r is 1/3. 2/3 over 2/3. Hey, that's 1. So it converges, and it converges just to the number 1. All right, let's look at one more. All right, it looks kind of similar, and again, it has the same typo, and I apologize for that. That should be a k there. Does 2 over 1/3 to the k plus 1 converge or diverge? And if you have constant numbers raised to exponents involving your index, usually it's n, but in this case it's k. Could also be like I or j. There's lots of other letters that could be used. Anyway, k is the index, and we've got 1/3 raised to the k, and that makes me think, okay, this is geometric, and I need to rewrite it in the correct form. K equals 0 to the infinity, a times r to the index here is k. All right, well, first things first, if I'm dividing by 1/3, that's the same as multiplying by 3, so I could rewrite this as an intermediate step. K equals 0 to infinity, 2 times 3 to the k plus 1. And then I can take one of those 3's out. That would be 2 times 3 to the 1, 3 to the k, right? All right, so there's my really messy scratch work up here, but 2 times 3 to the 1 is 6, 3 to the k, so there's my a and there's my r, but hey, don't use the formula. It's very tempting to say that's 6 over 1 minus 3, 6 over -2 is -3. But guys, that doesn't make any sense, does it? We're adding up a bunch of positive numbers. How the heck do we get a -3? And that's all bogus, because the formula only works when the absolute value of r is less than 1. But hey, 3 is greater than 1. And so from that, we know it diverges. So the formula down here where we got a negative number, that simply just does not apply for us. So the answer is it diverges.